We present OSVI-WM, a framework for one-shot visual imitation using world model-guided trajectory generation. Visual imitation learning enables robotic agents to acquire skills by observing expert demonstration videos. In the one-shot setting, the agent generates a policy after observing a single expert demonstration without any fine-tuning. Most existing methods train and evaluate on the same set of tasks, varying only object configurations, therefore, struggling to generalize to unseen tasks. Further, existing methods lack an explicit model of environment dynamics, limiting their ability to reason about future states. Let's look at some key challenges in our test setting. Firstly, the test tasks are different from training ones. Second, the expert and agent may have different embodiments, as shown here. Third, as shown in these videos, there is no direct alignment between expert and agent states or actions. Lastly, the method needs to be trained in domain. To address these challenges, we propose OSVI-WM. Its primary contributions include an efficient end-to-end imitation learning architecture trained solely on in-domain data, a novel world model-guided trajectory generation module for OSVI, and robustness enhancement at test time by using a waypoint controller with replanning. The expert demonstration frames and the agent's current observation are encoded into a latent space using a ResNet encoder. A world model-guided trajectory generation module predicts future latent states. These are processed through pooling and waypoint predictor layers to predict physical waypoints for control. During training, supervision is applied on the predicted waypoints and latent states. We evaluate our framework on 2 simulation and 3 real-world benchmarks. The test tasks for each benchmark are unseen during training. These tables show the success rates on the test benchmarks with OSVI-WM achieving the highest scores. To assess the impact of world model-guided trajectory generation, we perform ablation studies by removing the world model loss and the world model itself. Results show that incorporating both the world model and its loss yields the best performance. In this figure, we visualize the latent trajectory generated using OSVI-WM's world model decoded into images. We observe the following key points. The predicted trajectory captures task-relevant states, latent states enable interpretable reconstructions, and, as expected, later states become pixelated due to accumulated errors in recursive latent state predictions. In this slide, we show ablation studies that assess the impact of the different architectural choices. The remainder of the video presents imitation rollouts across all benchmarks. This slide shows the agent's performance using OSVI-WM on the MetaWorld Easy benchmark. Note that object and target locations differ between the expert and agent rollouts. This shows the imitation on the MetaWorld Hard benchmark. In addition to differing object placements between expert and agent rollouts, the agent must also perform finer movements to successfully complete these tasks. This shows the imitation on the pick and place benchmark. The embodiment mismatch between the agent and the expert adds to the difficulty. Next, we show videos on the real-world 2 Franca PP benchmark. In this setting, the expert and agent are mounted at different locations on a tabletop. In this human Franca PP benchmark, the expert is a human, thus increasing the embodiment gap further. This slide shows the human Franca push benchmark, which requires fine manipulation, as the task demands a low margin of error. Lastly, we show an example of OSVI-WM's replanning. When the agent fails to complete the task using the predicted waypoints, replanning is triggered. The model takes a new observation image and creates updated waypoints to complete the task. We proposed OSVI-WM, a novel framework for one-shot visual imitation for unseen tasks using world model-guided trajectory generation. This work is a step towards autonomous operation in several real-world domains.